Show that k squared minus 4k plus 5 is positive for all real values of x. We don't need to look into turning points here. I mean, that is one route you could go, but when you see this sort of thing, it's all about completing the square. That is a really efficient way of finding the maximum and the minimum. So we get k minus 2 squared minus 4 plus 5, and that will become k minus 2 squared plus 1. Now this is necessarily greater or equal to 1 because this here is always greater or equal to 0. And therefore, as a whole, it's going to be necessarily greater than 0. That's all we need to do. The second part, a student's trying to prove by contradiction that this equation has no positive integer solutions for x and y. Just really note that we're not interested if x can be negative or y could be negative. We're only going to look at the positives. And the start of their proof is as shown, they assume that there are positive integers x and y. So we're only looking for integer solutions to this equation, but then we're going to try and obtain a contradiction. So they've started it off. They've gone with 3x plus 2y is 14 and 2x minus 5y is 2. So they're looking for factors of 28 because if x and y are whole numbers, then 3x plus 2y must be as well. So that's all we need to. This wouldn't work in general, but it will work in this scenario because they're integers. And then they've successfully shown that we don't get whole numbers, so that isn't going to work. And now we've got to carry it on and look at other pairs, basically. So I really there are lots that you can try here, but you got to first of all think, right, in an exam, we're right at the end. It's unlikely that we're going to have to check lots of cases because you could check a lot of cases. And in the mark scheme, they talk about checking if 3x plus 2y is negative. But there's no way 3x plus 2y could ever be negative because x and y are both positive. So we only have to look at positive factors. There's another little shortcut we can make, which is going to mean we only have to check two other cases. And that is that it must be that 3x plus 2y is greater than 2x minus 5y. 3x is bigger than 2x for a start, and then I'm minusing 5y from the right-hand side. I don't think we need to prove that. I think we can state it must be larger than 2x minus 5y for x, y, positive integers. Okay, maybe I will explain it. 3x is greater than 2x, and 2y is greater than minus 5y. There we go, that's enough justification. So I only need to check factor pairs where 3x plus 2y is the bigger factor pair. Okay, so factor pairs of 28, well, we've already got the 2 and the 14, but don't forget 1 and 28. They're always a factor pair of any number. Like, if you had 10, it'd be 1 and 10, etc. And then 3 doesn't go into it, but 4 and 7 do. So what we're going to do first of all is set it equal to 28. Remember, again, the larger one, and 2x minus 5y is 1. And then in a minute, I'm going to do 3x plus 2y is equal to 7. Again, the larger of the pair, and the other one is going to be 4. And that is all we have to check. And furthermore, we don't actually have to solve these by hand. We can put them in our calculator. It's absolutely fine. So we're going to go to Home, and then to Equation, simultaneous equations, two unknowns. Let's type it in. And we get 142 over 19 and 53 over 19. So now we carry on the same sort of way and say they are not integers. So we've only got one more case to check. So if we can show these are not integers, that is it. If you press equals, it'll take you back to the original equation. So we only have to modify that right-hand side where we had 7 and then 4. So this gives 43 over 19 and 2 over 19. So these are the only possibilities, possible like pairs of factors, and hence we have a contradiction because we assumed there were integer solutions. We made the solution process using that, and we didn't actually get integer solutions. Therefore, the equation has no integer solutions. So hopefully happy with that. I'm just going to talk it through one more time. Feel free to stop if you've had enough. Okay, so look, we're assuming that this has integer solutions. Our process was then to say it's got to be an integer times an integer that gives us 28. So we only need to check integers that multiply together to give 28. That limits it to these. Remember, they're actually the positive integers as well. So no negatives needed. If we can spot it, it's going to save us a lot of time. It must be that 3x plus 2y is the bigger of the factors because we justified that. So they've already checked 14 and 2. We just had to check 28 and 1 and 7 and 4. In both cases, we didn't get an integer. So for our assumption, we've said this must be the case if there's integers, but then we haven't got integer solutions. This is a contradiction because we're saying that they were integers. It's quite subtle, but that is the contradiction part. And that means the original equation that does not have integer solutions. And that's what we had to do. Okay, a little bit technical, but yeah, well done. Keep practicing those proof by contradiction questions. And there are other ones on old papers on Edexcel. Actually, some of them you have to even sort of construct. You have to start with an equation and construct this sort of thing. So it can be even more difficult. Definitely do look into that. Well done on this old paper.